Namaskar, my dear friends. Let us talk about how we can utilize oscilloscope in NI Multisim. So basically, there are a lot of circuit design simulators or circuit simulation softwares where we need to utilize a real-time, like oscilloscopes and have a proper connection or interaction with the circuit. So what happens is, let us take this circuit. We have a voltage divider circuit, let us say R1, R2, with a zero point 0.3 volt peak 1 kilohertz signal. And as you can see, I am going to probe my oscilloscope positive terminal and negative terminal here. This is my ground, okay? And we will be seeing at channel A what is my output. So you can see very nicely that this input voltage is 0.3 volt peak, right? So the output voltage at this particular node will be what? Let us say V out. So V out will be R2 is 2 kilo ohm, right? So 2 multiplied by 0.3 divided by 1 plus 2, right? 1 kilo ohm plus 2 kilo ohm. So that is going to give me uh, 0.2 volt peak. So as you can see in the oscilloscope, we have here, like channel A scale that is going to be 100 millivolt per division. So this is 100 millivolt, 200 millivolt. So 200 millivolt peak and 200 millivolt troughs, right? So this is how you are able to see your oscilloscope proper, the waveform of this particular output. So if you want, you can like connect your oscilloscope in the circuit simulation and see a real-time waveform. So let us do this particular simulation in NI Multisim. So let us say, let us say I am going to open this. I am going to remove everything so that you don't have to worry about. Now my aim is, this is my resistor R1 and this is resistor R2. Our aim is to like see the waveform of V1, which is my input supply voltage, which is going to be zero point 0.3 volt peak and 1 kilohertz this thing. So what do you do all earlier? Go to voltage probe and let's say run it. Okay, so you'll see a voltage like reading here, but instead of this, what you can simulate is go to analyze simulation and go to transient simulation and let us say run it for 5 millisecond. Okay, so you'll very nicely see here that we have our waveform available, and that is going to be this. Understood? So this is my PR1 and PR1 is nothing but your input voltage at this location, 300 millivolt and 300 millivolt down with 1 kilohertz frequency, right? Now let us say this particular voltage probe I am going to put it here. So the divided voltage will be shown here. So let us run it and you can see the divided voltage is shown here at 200 millivolt, right? Because it will be 200 millivolt. Now we want to see the same waveform in oscilloscope. So for that, what do we do? If you want, you can directly come this side and connect your like required item. So the third one is actually fourth one is actually oscilloscope. So connect it like this is one method. If you do not find the toolbar or this icon toolbar, then what do you need to do? Come to here, like let us say view and then place. Let me check it where it is. Yeah, come to this simulate and then in simulate we have instruments. In instruments table you will see various items. Okay, so multimeter, oscilloscope, agilent oscilloscope. Okay, so all these things are there. So I am going to put a simple oscilloscope here. So let us say this is my oscilloscope present. I'll remove this voltage probe and I am going to check what is my input voltage and what is my output voltage. So for that I need to connect the positive terminal to let us say this point and ground to this point. Okay, and let us run it. So it is asking interactive solution. Let us do that and then let us run it. So if you double click this oscilloscope, you will see a proper waveform here. Okay, now to set the like oscilloscope scale and voltage division and all those things, what do you need to do? You need to set here scaling. So I am going to reduce the scaling to let us say 100 millivolt. So this will be 300 millivolt up, 300 millivolt down. So I am going to make it, let us say 300. So only one set will be there. And this one I am going to, let us say, make it like this. Okay. And trigger voltage I need to set, otherwise it will be little tough to view the waveform. Okay. So anyway, this you understood, like how to set this and how to like check your waveforms properly, right? So I am going to make it 200 millivolts. So 200 plus half of that, that is 300 millivolt output. Now now let us use another channel, or maybe same channel I will use. Maybe same channel I will use. Okay. So let us switch off that and connect this oscilloscope terminals to my output voltage. So output voltage is going to be at this location, and as I explained you in the theory part, like this should be zero point 0.2 volt, because 0.3 volt is complete total input voltage. So 0.1 will be dropped here and zero point 0.2 will be dropped here because it is 2 kilo ohm, right? And if I run it, this particular voltage will be how much? 0.2 volt up and zero point 0.2 volt down. So this is how you can use your oscilloscope to do the like readings. Okay. So if you want, you can like stop it for some time and see what is the reading that is coming. So you can increase the size also by dragging and like doing like this. Okay. So this is the way you can use your oscilloscope. So hope you have a good understanding how to put the oscilloscope in your circuit and measure the different voltage levels. So what was the method? I will tell you again quickly. Go to simulate, use instruments, whichever instruments that you want to use you can put down. So you want to use oscilloscope, put your oscilloscope, and any number of oscilloscopes you can put. So you can see XCS, XSC1, XSC2, XSC3. So if you have a very big circuit and you need to probe like a lot of different node points, you can use multiple oscilloscopes. Okay. So if you do have like any requirement or any understanding that is required more, you can put down your queries in the comment box and we shall be able to give you solutions as soon as possible. Thank you.